Good evening, fellow student. This is my first slide and it's on the subject data analysis and interpretation. This is the introductory slide and I am your instructor, Dr. Richard Kofi Aswabu. Since this is an introductory slide, I am going to assume that most of you do not have basic knowledge in statistics. Because of that, I am going to take my time and we'll go through each term that you need to know and understand before we delve into the data itself and then its interpretation. Thing is, what is statistics? Several definitions exist, but one of the good definitions I picked from one is that it is a science of collecting, analyzing, presenting, and interpreting, as well as making decisions based on such analysis. The key focus here is we collect the data in a scientific manner, following a scientific procedure. We analyze the data, present the data in a format that is presentable and easy to understand. Then we interpret. Based on the interpretation, we can make our decision. In a nutshell, then, statistics is just the numerical characteristic of a sample. So statistics has two general meanings. The plural meaning, that's the plural sense, and then the singular meaning. In plural sense, it is a numerical expression. Mathematics, which most of us do not like, including myself. It is reasonably accurate. Accuracy is relevant. It involves estimation, which we will be doing. And then it's a systematic collection of data. For those who have been in my class, I've always said that collecting data in a systematic manner is very key. And then relativity or relative, the feature of what? Comparison. You compare one set to another. In the plural sense, it has to do with multiple factors. We will be coming to that later in the course of this series of videos. One is we will look at regression analysis, where we can look at the multiple factors. For example, prices of commodity. It changes as a result of numerous factors. That is why in economics, they always use the term ceteris paribus or ceteris paribus, as some will say. All things being equal, because when things are not equal, some assumptions cannot hold. It deals with aggregation, GDP, unemployment. These are aggregates. Inflation, aggregate. Again, in a singular sense then, what is it? We've looked at it. Collection, classification, presentation, analyzing and interpreting quantitative data. What are the stages? First, we collect the data. And collecting the data is the beginning of the statistical journey. So once you start collecting data, you have begun your statistical journey. Second stage, you have to, after collecting the data, what do you do? you organize the data. Why? Because the data you collected can be in a very raw or chaotic format. Hence, there is a need to organize the data. And when you do a good organization, it helps to easily analyze, easily interpret the data. And in this class, we would mainly focus on some statistical tools. SPSS for starters, and those who want more advanced courses, we would focus on using our e-views and Stata or Stata. The third stage is you present your data. The assumption is once you organize the data, you are analyzing the data. And once you are done with the analysis, you present the data. How best do you present the data? Tables, graphs, diagrams. For easy and for starters, tables, graphs, and diagrams. I encourage. But fundamentally, graphs are of essence because when you view a graph, it is easier to understand. You analyze percentages, averages, correlation, regression, etc., etc. We would be looking at this later on. Correlation, associations, regression. We would look at it, and most especially how to interpret the coefficients. We interpret based on the tools we use and based on the model we apply. We interpret the data. Maybe example, we want to look at the degree of relationship between different economic variables. The relationship between inflation and unemployment, relationship between educational status and income at work, etc., etc. So let's go back. What are the various types of statistics? Descriptive statistics, which most of you might have done during in a subject called quantitative method. So in this subject, you learn to organize your data using graph display. You learn to look at what, apart from organizing it, you look at the summaries. So measure of dispersion, measure of central tendency, or what I call the 3 M's, the mean, median, mode for central tendency. Dispersion, you look at the standard deviations, and then look at the range of the data set. Then these are basic. That is why it is what? Descriptive statistics. And sometimes I tell my students, descriptive statistics are not really statistics, big time statistics. It is what we use in everyday, like the average, the mean, the mode, medium. These are basic. And it doesn't involve a lot of thinking. But there are some that involve quite a lot of thinking, making inferences. So the second type of statistics is inferential statistics. You infer from whatever you've done. There is also what we call population versus sample. What is a population? All elements. The keyword is all elements whose characteristics are being studied. Then the population that is being studied is called the target population. Again, because of the challenges in looking at the population, we look at sample. we take a sample. A sample is just a portion or a proportion of the population that is selected for study. So this is the whole population, and this is a sample. We select some few. We have what we call element. Element is just an object on which a measurement is taken. We have already looked at population, and this is a different definition. There is also what we call the sampling unit, which involves a non-overlapping collection of elements from the population that covers the entire population. The key word here, collection of what? Element. We have already studied what element is. We can look at census. Every member of the population. When you survey every member of the population, then you are conducting what we call a census. Now, we have what we call a representative sample. It's basically a sample that represents the characteristics of the population as closely as possible. The keyword, as closely as possible. A sample frame, a list of sampling units. You know what a sampling unit is. If you do not remember, just go over this video. You know what a sample is, but the key and most important is the word parameter. It's a numerical characteristics of the population. While sample is to statistics, parameter is to population. Key. So why sample? Usually we sample because the population is too large. You can sample the whole world. You can't conduct study using the whole world, so you sample. Again, because sampling reduces the cost. It's also time factor. You don't have all the time in this world to conduct everything. You are limited by time, so it is important. And also because impossibility, or it is not possible to identify all the units. So you go in for population, we have done. So in sampling, if each member of the element of the population has an equal chance, then you go for a random sampling. And in random sampling, we have what we call a simple random sampling. That is, if the sample of the same size is selected from the population, having the same chance of being selected, we say it is what? A simple random sampling. A sample that is drawn such that each element of the population has a chance of being selected is what? A random sample. The approach is what? A simple random sampling. So we can sample with replacement or without replacement. So it's just like a ball. When I pick a ball from a collection of balls and I replace it back after picking, then we say with replacement. If I do not replace it back, then we say it is without replacement. We've looked at the elements, which can also be referred to as members or a member. So I am not going to go over it. You can read it or listen to the other earlier slides. What are the basic terminologies? Variable. The characteristics under study that assume different values for different element. And this is in contrast with what we call a constant, which is what? Fixed. Constant is fixed. Variable assumes what? Different values. The values of a variable of an element is called an observation or a measurement. A data set is what? A collection of observation on one or more variables. So this is an element and this is an observation or a measurement. Types of variables. We have what we call the quantitative, which can also be subdivided into discrete and continuous. And we have what we call qualitative or categorical. If you can measure the variable numerically, then we say it is a quantitative data. If you can measure a variable, then it is what? Quantitative variable. But if you are looking at the data collected on a quantitative variable, then we say it's what? A quantitative data. A variable whose value are countable are said to be what? A discrete variable. You can count them. In other words, we say what? Discrete variables can assume only certain values with no intermediate value. 1, 2, 3, 4. These are discrete. Or a continuous variable. Assume numerical variable over a certain interval. So between 1 and 0 or between 0 and 1, you can have so many variables and continuous variable. 0.1, 0.2, 0.3, these are all continuous variables. Then again, we have what we call qualitative. Remember, somebody will say it is the opposite of quantitative. Yes, it is, but what is the definition? It is a variable that cannot assume a numerical value, but can be classified into two or more non-numerical categories. I repeat, it is a variable that cannot assume a numerical value, but can be classified into two or more non-numeric categories. So, for example, the sex of an individual is either a male or a female. So, easy and a snapshot. The Professor Phil and the field does a good work representing this framework. So we have a variable and be quantitative or qualitative. If it is quantitative, it can be discrete or continuous. Then he gives various examples. Okay, so we have, what about the time interval when the data is collected? We have what we call a cross-sectional versus a time series data. Cross-sectional, what is it? Data collected on different elements at different points in time. For example, different elements at what? At the same point in time. Data collected on different elements at the same point in time or for the same period of time. Time series data collected on the same element for the same variable at different points in time. Remember, cross-sectional, different variable at the same point in time. Time series, the same element at the same element for the same variable at different points in time. What can we then say? How do we get our data? It may be sourced from internal within the working population, internal from where you find yourself, maybe from home, external. It can be sourced from other agencies like the World Bank, etc., etc. Or you can personally conduct a survey or an experiment. These are the references of the source for those who are interested in further reading. Remember, go through the various points. Take your time, watch this video over and over again. Thank you very much, and I hope you did enjoy this introductory video. See you in the next section. Bye.